All right, today we're going to dig into a pretty revolutionary idea in plant health. What if, instead of constantly spraying problems away, we could just build plants that are physically immune to pests and diseases from the get-go? We're going to look at the HBNF Hemp protocol to see exactly how that's done.
So, let me start with a question for you. Think about the plants you grow. Are they actually healthy, or are they just surviving? Propped up by a constant stream of fertilizers and sprays. That distinction, that is at the very core of what we're about to explore.
This quote right here, it perfectly captures the whole philosophy. The idea is that pests aren't the enemy. They're nature's cleanup crew, the garbage collectors. They show up to take out plants that are already weak and metabolically broken. So if you're fighting the pest, you're really just treating a symptom, not the actual disease.
Okay, so to build a genuinely healthy plant, you need a map, a guide, and in this system, that map is the plant health pyramid. Don't think of it as just a theory. It's more like a metabolic staircase that a plant has to climb step by step to reach true unshakable immunity.
And here are the 4 levels of that staircase. At level 1, the plant is just making simple sugars. I mean, it's alive, sure, but it's basically junk food for bugs. At level 2, it starts building complete proteins, which makes it a little less tasty. But the real game changer, the breakthrough, is level 3, lipid synthesis. This is where the plant literally builds its own armor. Level 4, well, that's the pinnacle, total systemic immunity.
So if this pyramid is the pathway to health, why do so many plants get completely stuck at the bottom? Well, the problem usually comes down to what we're feeding them, which, without meaning to, turns them into what the source material calls bug food.
The truth is, the vast majority of modern agriculture has plants just spinning their wheels right here at level 2. We pump them full of nitrogen, but they often don't have the right trace minerals to actually use it. This creates a huge metabolic traffic jam, and the plant sap just fills up with all these half-finished, unusable nitrates and proteins.
So what are these incomplete proteins? Think of them as raw building materials the plant can't finish assembling. But for a pest with a simple digestive system, that nitrogen-rich sap is like an all-you-can-eat buffet. The plant is basically ringing a dinner bell, inviting pests to come and eat it.
And this is where hemp seed enters the story. To break through that level 2 ceiling, the plant needs to build a physical defense. This protocol points to hemp as the ultimate shield builder, the one thing that can unlock that next level of health.
And that defense is what's called the lipid shield. See, when a plant has extra energy, it stores it as fats, or lipids, right on the surface of its leaves. This creates that shiny, waxy layer you sometimes see. This isn't a chemical defense, it's straight-up physical armor. It's like putting a bulletproof vest on every single leaf. And this isn't just some vague concept. It's something you can actually measure. As this chart shows, a standard plant might have a leaf lipid content of about 2%. The goal of this protocol is to more than double that, pushing it up past 4%, even towards 6%. That single increase is the difference between a vulnerable plant and an invincible one.
So why hemp seed? What's so special about it? Well, for one, it has the perfect omega-3, 6, and 9 fatty acid ratio. These are the literal building blocks for that waxy shield. By spraying them on the leaf, you're giving the plant prefabricated parts, which saves it a ton of energy. And that saved energy can go straight into more growth and a stronger immune system. And maybe most importantly, this lipid layer is physically too tough for fungal enzymes to break through. Okay, so we know what this shield is, and we know hemp seed is the builder. But how in the world do you get those big, heavy lipid molecules inside the plant? It's not as simple as just spraying some oil on a leaf. You need a key.
You can think of the plant's cell wall like a locked door. It's specifically designed to keep big, clunky molecules like fats out. The key that unlocks that door is fulvic acid. Fulvic acid actually makes the cell membrane more permeable, basically prying the door open just long enough for those hemp lipids to sneak inside.
Now, how you mix this is absolutely crucial. You can't just dump everything in a bucket and stir. You have to follow what's called the vortex rule. As you can see, you add the key, the fulvic acid, to the water first. That conditions the water. Then you add the shield builder, the hemp. Mix it all up and spray it on the leaves at dusk to avoid any leaf burn.
So you've done all that, you've followed the protocol, but how do you know if you actually built the shield? The cool thing is you don't have to guess. There's a super simple visual test that proves it worked.
This is the moment of truth, isn't it? How can you actually verify with your own 2 eyes that this invisible armor is up and running? Okay, check this out. 24 hours after you spray, you just take a simple water mister and spray the leaves. If the water just kind of sheets out and makes the leaf all wet, like on the left, you failed. The shield isn't there. But if the water forms these tight, high spherical beads, like water on a freshly waxed car, that is a pass. The hydrophobic lipid shield is active and working.
And the biology behind that is just brilliant. That water-beating surface isn't just for looks. A fungal spore, something like powdery mildew, it needs a film of moisture on the leaf so it can germinate and start its infection. By creating a surface that physically repels water, you deny the pathogen the one thing it needs to even get started.
And that brings us to this final powerful idea that really sums up this whole shift in thinking. Instead of waiting for a problem to show up and then reaching for a fungicide, this is all about proactive defense. It completely reframes the question. We stop asking, how do we kill the pathogen? And we start asking, how do we build a plant so well defended that the pathogen starves on the surface, unable to ever get a foothold in the first place?